Hello, everyone. My name is Tricia Smith, and I'm Director of Product Marketing for GE MapSight. It's my pleasure to welcome you to our webinar entitled SPIDACalc and GE MapSight, Weaving a Seamless Solution Through Integration. MapSight and SPIDACalc are each very capable standalone solutions. However, we've had a number of inquiries requesting a direct integration between the two products. We're delighted to tell you today that the integration process is almost complete with an anticipated release date of September 1st, and we're using this venue to share details about how it works and when and where you can get it once available. Before we move into the presentation, I wanted to let you know that we will respond to any questions at the end of the presentation, but do feel free to send your questions during the event. There is a chat box available to the left of your screen where you can type and send us your questions. We will make every effort to ensure we get them all answered, and if we need to follow up offline, we can do that also. At this time, I'd like to introduce our two presenters, Mr. Brett Willett, Vice President at SPIDA Software, and Mike McGill, Director of Sales for the Americas with Ike GPS. Each will be providing some basic information surrounding their products and offering demonstrations of the new integration. At this time, I would like to turn the webinar over to Brett Willett from SPIDA.
All right. Thanks, Tricia. Good afternoon, everybody. Again, Brett Willett with SPIDA. Before we move into talking about the integration, I thought it would be appropriate here just to maybe talk a little bit about who we are at SPIDA and some of our products, and then talk specifically, since we are here to really look at SPIDACalc and the integration with MapSight. So SPIDA Software. So who are we? Where are we located? Who are our customers? So we were founded in 2007. We're headquartered out of Columbus, Ohio. We came to market with our first generation of SPIDACalc back in 2009. Today, it's nice to say that we have a customer base of several hundred customers now located coast to coast in the United States. We have a large group up in Canada, and we extend all the way down into the Caribbean. So what is it that makes SPIDA unique, I guess, when I look across the landscape of different vendors and different products that are out there? I think the one thing about SPIDA that's unique is that we're exclusively focused on the physical asset. So our customers, and they're made up of electric utilities and telecommunication companies, as well as their contractors that provide them services. For us, SPIDA, we have the singular lens and focus of trying to help those companies better engineer and better manage that physical asset. And so all of our products, and there are three of them for us that really constitute the cornerstones of what we call our structure management system. And these products can be used individually, or they can be used together as a platform. So SPIDACalc, I'm going to touch on again a little bit more in a second. So I'll move down at the bottom. You can see, so SPIDA is our asset administration platform or project management tool. It's a map-based system that's a workflow-driven system that our customers are using to automate and optimize business processes, such as joint use and pull attachments, transfers, and violation notifications, as well as things such as system inventories, inspections, such as a pull inspection process. SPIDA is our newest product that we launched earlier this year. So it provides a centralized platform where we can aggregate all of that SPIDA-centric data. And for us, what SPIDA does is that gives our customers a way of aggregating and better managing, their SPIDA project files, as well as being able to hook into that information for reporting, and then also those critical return visits sometimes back to that asset. They can quickly go back and retrieve previous designs and previous work. So just very specifically, just to move over, so talking about SPIDACalc. So SPIDACalc on its surface, we've tried to craft in a way that it's going to fit with many different types of user groups. It provides both not only a drag and drop interface, but also a tabular interface. So depending on, how the users are more comfortable in interacting with their design and their work, they have both environments at their disposal. We provide 3D modeling and rendering of the structure after the analysis has been conducted, providing some color coding and shading so they can very intuitively and visually see the stresses being applied along the entire length of the structure. And there's also some complementary tools, including some photo measuring, embedded map with GPS capabilities, as well as some form acquisition and some form capabilities inside SPIDACalc. And that's really something that we're hoping that we're going to be able to better leverage as the evolution and the integration with MapSight continues to evolve. So for us, underneath SPIDACalc, I think one of the things that we're most proud of, I guess, is really the engine. So SPIDACalc is a geometric, nonlinear finite element analysis. And in simple terms, that means we run a whole bunch of math when you click the Analyze button. When we review your design, we tell you whether it's meeting the applied safety codes, and we support currently, the NESC, CSA for those Canadian users, Geo 95 for those out in California, as well as be able to create and customize your own custom load cases. And then we analyze both wood and non-wood products, and we're analyzing not only the structure itself, the pole from pole loading, but also a comprehensive review of the remaining strength if you've applied damages to a wooden structure, pole foundation, anchors, guides, sidewalk struts, cross arms, and insulators. So for us, our users really kind of fall across a very broad spectrum within our clientele. SPIDACalc gets used for not only new design, but also evaluation of existing structures, standards development, joint use in the pole attachment process, as well as pole inspection. So as you can see, these are all areas and aspects that are going to benefit greatly from the integration that's been done with MapSight. And so we're really, optimistic and excited about the work that's been done and looking forward to the things that are to come. So with that, I'm going to turn things over to Mike McGill, who's going to tell us more about MapSight.
Thank you, Brett. I appreciate that. Thank you, everyone, for joining us. I noticed we've got more than 110 people logged in today, and we appreciate you joining us. We're excited to share this preview with you of our integration with SPIDACalc. For those of you who don't know IkeGPS, we're a company that's focused on improving efficiencies and data quality for people who need to map and measure assets in the field. The primary applications we focus on, as you'll probably tell from this presentation, are those that require mapping and measurement of utility poles. We've been in business since 2006 and have established ourselves with electric utilities, communication companies, and engineering service providers around the world. Most notably, our solutions are deployed extensively across the U.S. military and approximately 250 utilities. We have a global presence. Our corporate headquarters is in Wellington, New Zealand. We're actually publicly traded on the New Zealand Stock Exchange, and then our global sales, marketing, and product management is based in Colorado. And we have strategic partnership agreements with InQtel for providing solutions to the U.S. defense intelligence community. And then we have a global trademark and licensing agreement with GE. This basically means that MapSight is sold under the GE brand, which means MapSight meets GE's product quality and reliability standards, which is very important to our customers. And then while MapSight carries the GE brand, it is developed, manufactured, and distributed by IkeGPS. MapSight's used for a variety of applications. The applications that we're focused on delivering complete solutions for are those that help people around utility poles. Some of these applications you're all very familiar with: new attachment permitting, joint use audits, post-construction as-built audits. Basically, all these applications, the common denominator is that all these applications require accuracy, better productivity, and they all benefit from providing photo-verifiable evidence for the measurements that are collected in the field. So to provide an overview of MapSight, MapSight, basically our solution, has three main components, or actually it falls into a very simple workflow, which is around planning, capturing data, and then delivering the data to the applications that you use most. The planning part requires our desktop software, which, by the way, is freely available to anyone. You can go to our website and download our desktop software if you want to evaluate it. But on the planning part of the process, people use the desktop software to create forms that reflect the way that they want to collect data in the field. So we provide a series of tools that automate things such as collecting down guys or backspans or collecting midspans or collecting a calibrated image of a utility pole for measuring attachment heights. And we let you mix and match those tools into a form. Now, in the context of today's presentation, the form is actually generated using the client file from SPIDACalc. So that has a big impact on the form creation. But that form is created in our desktop. Very simple thing to do. We give you a lot of flexibility. Once you've created that form, you then deploy the form to the MapSight device. And the MapSight device is what you use in the field to collect the data. The device is unique because we have combined a sub-meter GPS, digital camera, laser rangefinder, a compass, and an inclinometer, all in a ruggedized Windows-based mobile computer. So all the things that you were used to using in a disconnected or analog world are put into this device, which really then contributes to productivity, accuracy, and consistency of data. Finally, once you've collected the data in the field, then you go back to our desktop software. You download the data into or publish the data into our desktop software. And there you have the ability to do things such as measure heights of attachment. So instead of hot sticking that information in the field, you can actually do that in the back office and achieve an accuracy of an inch or better on heights of attachments. And the other function you perform in the desktop software is then you make the data available to a variety of applications. And the example today obviously is pole loading. So based on what we've presented so far, I think the logic behind creating the integration is pretty apparent, but I think it's still worth noting. We're seeing that a number of pole owners, increasing number of pole owners that require pole loading, and this is on the rise. And this creates a challenge for people who are tasked with fielding and pole loading the data, or in California, wind loading the data. If you operate in an environment that does not require pole loading, you might be able to get away with doing things the old-fashioned way. But as soon as you add pole loading to the equation, you're potentially adding a significant increase in time and resource. And if you don't use technology and automation to your advantage, then you're just going to be behind the curve. So the integration of MapSight and SPIDACalc gives you a way to standardize field data collection, produce better data, and in most cases reduce the time and necessary resources for fielding. And the quality and the consistency of the data will have the added benefit of eliminating the need to perform, or certainly dramatically reducing the need to perform field verifications to ensure data quality. Most of the subjectivity associated with the current way of doing things is really eliminated because you have photo verifiable evidence for all your measurements. Now that you have the data, okay, once you've got the data, then you can eliminate the need to transcribe data from the field into SPIDACalc. And then that data is quickly and easily available to SPIDA so that the pole is built for you. This means saving significant time per pole and increase your ability to deliver projects on time and on budget. Brett, is there anything you'd like to add to that?
Yeah, thanks, Mike. I think I'm very excited about is the fact that the work that that's being done here with MapSight and the integration, I think it's really providing our customers with a good way of addressing the field data collection scenario. Obviously SPIDACalc gets used in a lot of different ways, and so as such, it's a very diverse platform. I think with the work that you guys are doing, I think we're providing a great solution that really helps them get data into SPIDACalc where we can leverage that powerful engine and then help them support their daily process.
Yeah, obviously I agree, and I really think the industry mandates this, so I'm glad that we're doing it. Okay, so let's jump into the overview of the integration, and then we'll dive into a demo. So at a high level, what we're doing is starting on the front end of the process. So if you remember, we have the planning part in the MapSight workflow. So the form creation, in this case, is really generated using the client file, the SPIDACalc client file from the customer. And as you know, that contains really all the information from a customer about what exists in the field and what exists on a utility pole. So we basically, in the MapSight desktop software, with a button, using the customer client file, we create the MapSight form. That gets published to the MapSight device. The user then goes out in the field and collects the data like they normally would. Except the main difference here is they have the data that is specific to the customer. And then once that data is collected, you go back to the desktop software and annotate the poles. Once you've annotated the poles for heights of attachments, you then have a button that generates a JSON file or a SPIDACalc project file, and then SPIDACalc is automatically launched, and that project file, which contains all the poles that you've collected, is then loaded into SPIDACalc. So, showing that in a little more detail, this is giving you a feel for what the form looks like. So again, we create that from a client file. That then goes into a MapSight form. These are the different tools that you select on the device. These are actually screenshots from the MapSight device. And then again, you go out in the field using that form, which guides the user through the process of collecting the data. And once that data is collected, then you annotate the poles and then generate a report or a SPIDACalc project file, and you're done. So let's look at that in the real world. Share my screen with you. Okay, so Brett, can you be my eyes on the other side? Can you see the MapSight desktop?
I see it.
Beautiful. This is working, and I'm not muted, so we're really going now. Okay, so yeah, life is good. So this is the MapSight desktop software. And in the planning part of the process, this is where you would go to create a form. And typically what our customers would do is they would drag and drop these tools, like, so for example, a span height. If they wanted a span height as part of their collection process, they would add that into the MapSight desktop. And so other tools like a target position to get a location for an asset. And by the way, because we have a laser rangefinder built into the device, if you want to get the location of an asset, you don't have to be standing at the asset to get a location. You can be standing at a safe and comfortable distance to get that information. So normally our customers, or traditionally our customers, would build these things step by step and try to mimic their workflow and the use of the tools. But with the integration with SPIDACalc, and because the customer's pole information has such an impact on what we're collecting in the field, we've replaced that manual process with a SPIDACalc button here that when I push it, actually, we'll skip the step here. When I push it, we'll create a form for you. And just to show you something under the hood a little bit, basically what we're doing is we're referencing in our integration the client file. So you could have a long list of, you're a contractor and you've got multiple customers, multiple client files. You can load those and have them visible to MapSight. In this case, I'm just showing you one client file, the demo client file that we have for today's presentation. So in referencing that client file, all I need to do is, push that SPIDA button. And all of the information that was made available to us from the customer's client file. I'm jumping over to SPIDA here. And Brett, can you see SPIDA on your screen?
I can. Yep.
Beautiful. Okay. So all the stuff that's coming from the customer's client file is automatically reflected in MapSight. So, for example, poll type. All the information about the customer-specific poll type is there. Information about specific anchors are there. So all the information that the customer would collect, or what I would refer to as the worst case scenario, if you had to collect everything, you had the worst, messiest poll out there, that worst, messiest poll is represented in this form. You don't have to use all of these tools. It's really dependent on the sophistication or how crowded that particular poll is. But the customer's data is automatically then generated and made available in the MapSight form. So what I would do is from here is I would save the form, and then I would deploy the form to the MapSight device just by hitting that button. Okay, so it's available then on the device. And the user then goes out into the field and collects the data. Once they collect that data, I import that job into the MapSight desktop software. Here are a couple polls that we collected using the form that I'm showing you here. So I've got the job here for a couple of polls. And the way MapSight organizes data, so you can create a series of jobs, and then for each device, we then have a file for each poll. So you can actually go in and look at all the data that was collected for each particular poll. So in this case, you can see we had the date of collection, poll sequence, poll ID, the poll type, photo of the poll tag, various photos that we collected. Everything is provided in a nice, neat, and convenient place. And again, if there's in the collection form, it doesn't mean you necessarily have to collect it. You can skip it if it's not there, obviously, but we want to create a form that is a worst case scenario. This is a true size image. So this is an example of where we go to collect attachment, or where we go to measure attachment heights. And the unique thing about MapSight is we've combined the laser rangefinder with a digital camera, and this is actually technology that we've patented. So we create a calibrated image of the poll. You don't need an external calibration stick. You can stand there with the device, take a picture of the poll using the true size image tool, and you will have a calibrated image that when you measure anything on that image, you will achieve an accuracy of an inch or better. Now, an interesting thing about what we've done with the integration is that in many cases, if you try to measure all the attachment heights on one image, the image starts to get pretty crowded. So we've given you the ability to look at the poll from multiple angles and to measure attachment heights based on which photo represents the best angle for measuring those attachment heights. And measuring something on a poll is as easy as, clicking on the image and then just measuring. Okay, that element on the image. Now you'll see here that we're using very specific nomenclature for this particular collection, and that's it. So that gives you a feel for the data, the quality of data that we collected in the field. Again, there's really no shortage of data here. Here's an example of some of the photo verifiable evidence for in this case, a forward span. So every time we do a point-to-point measurement, not only do we capture the measurement, but we emboss that measurement on the image. And so that makes the data more trustworthy for the customer. This is one of the things that minimizes the number of field visits. So that gives you a feel for the data we collected and the interaction within the MapSight desktop software. So once I have collected that data, I've gone in, annotated, created the heights of attachments, then all I do is I simply click the SPIDACalc project button. Whoops. There we go. I had an error because I'd already generated the report. So the report is here. Once I've created the report, then I can just simply click on that report, and then it will launch SPIDACalc for us and load that data automatically into SPIDACalc. So with that, I'm going to hand it over to Brett so he can pick up where I'm leaving off. So we've gotten to the point where I've generated the JSON file for SPIDACalc, and now it has opened SPIDACalc for us, and you can pick up from there. So Brett, why don't you take it away?
All right. Thanks, Mike. One sec here. Let me go ahead, and you can help me make sure that I'm sharing as well. Let's see. 1 second here, everybody.
There we go.
Excellent. So I'm assuming you're seeing SPIDACalc now?
Yes, we see SPIDACalc.
Perfect. All right. All right. So what I have here is the SPIDACalc exchange file that Mike generated over on his side, I have now open inside the SPIDACalc environment. Once you're inside SPIDACalc, I mean, this is essentially a SPIDACalc project file. And now I have the full complement of SPIDACalc tools and functionality available to me as an end user, where I can go on and go through a review, an analysis, or continue on with whatever business process, whether, again, it's joint use or I'm doing a new design, whatever it is that my function is, I'm able to kind of pick up and carry on. So you can see just really quickly, not to spend too much time, but I have within the SPIDACalc interface, you can see over here on the left-hand side, by opening up this project file, you know, I can see I have the 2 polls that Mike had on his side. And then above this, I have all those photos, and I can undock this image here. And I can pull this out a little bit, and you can see I have the full complement of annotated photos that were provided from the MapSight device, open inside SPIDACalc as well. So a couple of things you know, that we want to make everyone aware. So with the this early iteration with the integration, there's a few things that users are going to have to do on their side. Obviously, you know, the expectation is moving forward. You know, the amount of interaction, the number of structures that the users are going to have to physically come in and touch and you know, make edits to. You know, obviously we're looking to I think the intent is to optimize that and minimize how much interaction is going to be required here on the SPIDACalc side. And Mike, if there's anything along the way, by the way, that you'd like to add, feel free to chime in. So what I'm going to do now is there's a couple of things here with these 2 polls, and I can kind of click down through. I can click on this other design. You can see that I have both of them here, and again, I have the images corresponding with each location. So just for today's purpose, I'm going to take my very first poll here, this poll 54402, and I have a measure designed for it. And there's a couple of things I already see that I'm going to need to clean up. The first thing I'm going to do that a user is going to have to do is I'm going to come up here under the project settings window, and what that's going to do is it's going to bring me into the client file settings for this and the project settings for this particular project. And I'm going to come over here under the loadings tab, and for today I'm just going to pull in a NESC medium grade C load case. I'm going to apply that to my project so that when I hit the Analyze button, we're going to take the requirements as set forth under the NESC grade C requirements for the median loading district, and we're going to evaluate that structure and all the components to determine whether each component meets code requirements or not. I'm going to move over then. I'm also going to come over here by a strength case, a strength evaluation as well for my structure, if there's any other information coming through regarding damages. And then just simply need to click the OK. So that's a required step, you know, for this initial integration. The other thing, as you can see here, as you're looking, if you are familiar with the SPIDACalc interface, you can see in the side and the top view here I have my structure, and then on the top I have kind of a layout for this particular design. You'll notice I'm going to come in here and I'm going to select some of my adjacent structures. And one of the items that we're going to have to do is I'm going to have to come in and update a couple of the wire endpoint types. I'm going to switch these adjacent structures, and I'm just going to left click on the other wire endpoint type, and I'm going to update because right now they come through as next wire endpoints. That's kind of a known limitation, something that obviously I think will be addressed in the short term. And then I'm going to come down and I'm going to select one of my remaining 2 structures in my main line and my main span, and I'm going to change one of these to a previous wire endpoint as well. So now I have kind of my previous next and a couple of adjacent structures here. Working within the SPIDACalc interface, one of the other things that you'll see is that all attachments are going to come in right now as assigned to a default, what's termed default ownership. I can go through and use SPIDACalc now to update and assign specific owners to all the various attachments as I'd like and as I need, and I'll show you how to do that as well. One of the first things I'm going to do is I've got you can see here with our structure is kind of a tangent construction here, double set of arms. The cross arms right now are coming in with an offset of 5 feet. I'm going to change that so it's I have an 8-foot set of double arms. I'm going to change that so the offset now is kind of bisecting where I have 4 feet on either side. And then here I'm going to take, I can see I've just got a single phase, and again we're relying very much so on the data collection that's done in the field and in that end user, because all of that field collected information is going to land and populate what we see here in SPIDACalc. So really this is kind of taking on more of a QC capacity more than anything. So what I'm going to do is I can see my one phase on the arm was kind of placed, and I think that's also a kind of a known limitation right now, where the spacing along the arm is not something that necessarily can be handled on the MapSight side. So it is something that a user would have to do and come in and correct the spacing on the arms, at least initially. I'm going to update my single pins here and change that into a double pin insulator configuration. I can do that just by updating from a single insulator to a double. And I can see I've got a missing phase over here. So I'm going to go ahead and going to quickly add another pin insulator, double insulator to the cross arm. I can just do that by dragging directly to the arm. So I know I have the pin position here. And then what I'm going to do as well is I'm going to just select my 2 conductors up on top. I'm going to copy those, and then I'm going to come over to my insulator on the other side, and I'm going to paste them. So now I have my 2 phases on the arm. And then the other thing we can see here that I want to correct is that during the data collection, again, just kind of a verification, if I undock that photo, we can see I want to get that ridge pin. So again, a data collection point. I'm going to get that that pin right now is kind of shown below the arm. I'm going to get that moved up. And again, this is something I could use, either go back and review the annotate, or I could use some of the photo measuring available inside SPIDACalc. But for today's brief purposes, I'm just going to go ahead and slide that pin up to the top of the pole. And then just to show just showing updating of the attachment ownership, if I look here down in the communication space, when I click on a wire attachment, we can see that right now I've got a communication attachment and it doesn't have an ownership assigned to it. So I'm going to need to do that if that's something that's important to me for my use case and for my business. So I'm going to say that, hey, Bob's Cable is the owner of this particular attachment, and all I would need to do is just left click and drag this down, and we can see now that I've assigned Bob's Cable as the owner of that particular attachment. So that process would have to be repeated right now for each attachment on the pole, or for those attachments that you are trying to assign ownership to. Once I've done that, what I can do is just simply go through and click on the Analyze button here, the play button as we simply refer to it. And at this point now we're engaging the engine, and SPIDACalc's going through a full 360-degree wind sweep, wind rotation. We're analyzing all the components on the structure, and you can see here obviously the structure is not meeting the NESC grade C requirements. And then as part of my normal remediation steps, I can continue through using the tools inside SPIDACalc until either I've corrected this or if I've noted some other data collection issues. Obviously this work could be reallocated back out to a technician to be returned to the field. So Mike, with that, I don't really have that kind of wraps up my portion of kind of concluding the process of getting the poll analyzed. So what I guess I'm going to do now is turn it back over to you.
Yeah, thanks, Brett. And really the only thing I can add to your presentation, very well done by the way, is that this phase, the goal of this phase, the integration, is to prove that we can get the data from MapSight into SPIDACalc, and in the process of doing that, help and hopefully have a dramatic positive impact on productivity. The next phase is all about getting to the point where we can minimize the number of times you actually have to touch the poll or clean up the poll once it's brought into SPIDACalc. But I think this the level of integration we're showing today is going to have a significant and positive impact. So thank you for showing that, Brett.
My pleasure.
Okay, so just as a summary, quick overview, is we're very simply using the SPIDACalc client file as the input to create a form for collecting the data in the field, deploying that form to the MapSight device, going into the field and collecting data with the goal of being more efficient around the poll and collecting better data in the process. And once the data is collected, come back to the office, annotate the data, and then push that data out to a JSON file that automatically loads the polls into SPIDACalc, and then you're there to assess the polls, do any cleanup that's necessary, and finish the project. We're hearing from our customers that this integration will help shave off anywhere from 30 minutes to an hour per poll, and in some cases more. And so we're excited about delivering that level of integration. As Tricia had mentioned, we've got an anticipated release of September 1. We'll actually be announcing the release on September 1st, and then we'll be providing a series of informational sessions that will provide more detail, and stay tuned for that information that we'll be sending to everyone that's on this webinar. We'll be sure to send this information to you on September 1st. With that, I would like to go to questions and answers. I've seen a series of questions come up, scroll by on the screen, so let's go ahead and open things up to Q&A.
Okay, thank you, Mike. We do have quite a few questions. Again, feel free to send them through. We'll do our best to address them. So our opening question is, how is poll ownership and identification determined? And Mike and Brett, I'll let you guys decide who wants to answer that.
Brett, do you? I think that's more of a general. I'm not sure I understand the question completely, so sorry, I'm punting over to you.
Yeah, no, that's all right. Yeah, no, and I think that's one of the, again, I kind of touched on it briefly, as I was kind of going over, after the data was passed into SPIDACalc. Right now I think the current iteration, this initial iteration, I believe is just assigning to a default owner. My understanding is, and maybe Yan Peng would like to weigh in on this, but my understanding is that moving forward, this is maybe an area that could be revisited. Again, it's really reliant on, the data collection in the field. Owners can certainly be assigned to things in SPIDACalc. All attachments, both the poll and all objects, can have their own discrete ownership, and it's really just how much we want to put that responsibility on that data collector.
Great.
Yeah, thank you
for the clarification on that, Brett. I did want to mention that our Director of Product Management, Yan Peng Wolf, is on the call with us, and we will defer to her if we get into a technical conversation, because she is the expert on the product.
Well, and actually, Tricia, for this next question, I'd like to defer to Yan Peng, just because I don't have the version number right in front of me. What version, Yan Peng, what version of MapSight is going to be required for this integration?
It's going to be version 3.3.0, and the version you are using for the demo right now is the beta version of the final release.
Okay. Will there be an upgrade required for the software on the device also?
No, there won't be any upgrade on the device tools.
Okay, so the current version of the device software will work.
Yes.
Okay, beautiful. Thank you.
Yeah, and just to add from the SPIDA perspective, what is supported, the version of SPIDACalc that would be required would be just on one of our newest releases. Any of the version 6 releases of SPIDACalc would be compatible with the integration.
Great. Thanks for the clarification, guys. Our next question is, do attachment heights need to be entered into MapSight first before generating the report to load into SPIDACalc?
Well, yes. Practically speaking, yes. If you would still be able to build the pole if you didn't enter those heights of attachments, but obviously they wouldn't be there in SPIDA once you created the SPIDA project file that for MapSight.
Why are all the insulators dead ends?
Yeah, and I think in this particular project this particular sample set of data, again, it falls back on the data collection process done in the field. So I think if insulator types are something that's defined in the client file, that becomes so when you're generating the form for the MapSight device, those selections are dependent on the client file, and then by extension by the person at the pole.
Excellent. Thank you. Our next question is, can ownership be collected as part of the field process?
Yes. Yeah, that can be easily added into the MapSight form.
Okay, and continuing, can the environment be recorded for each bay or span?
Sorry to put you under the gun, Brett. Do you mind taking a stab at that?
I can do my best for sure, and if I say something egregiously out of line, or for sure, I can always be corrected. So in SPIDACalc, just for those that maybe just to provide perspective, so in SPIDACalc, you can assign an environment or a terrain associated with the various spans for every pole. So currently that is not being collected, but I think, Mike, what the response would be is probably yes. I would say probably yes, just because I'm hedging myself. But I think yes, that it could be something that's collected, on a form on the MapSight.
Yan-Ping, do you have anything you want to add to that answer?
Yes. So the MapSight form that we created from the button that you just saw during the demo, it created a standardized data collection form. But you also can add additional fields to the form if you want to. For example, midspan height and damage assessment, those kind of fields you can add to it, provided that you do not change the structure of the existing form, because that standardized data collection form has a data structure that's built in order to support the integration. So yes, you can add additional fields.
Okay. All right, thank you.
Our next question is, how does GE MapSight collect midspan heights? I believe they're referencing that there wasn't any showing on the SPIDACalc example.
Well, yeah, I think it was showing 0 feet 0 inches
right
on the example. So I'm not sure exactly. Well, I'll answer the first part of the question, and then I'll let Yan-Ping and Brett respond to the second part. We have a midspan tool that's built into MapSight, and basically what that does is it directs the user to identify the starting point or the conductor that they want to use for the starting point. And once they've identified that, there's a arrow button on the MapSight screen. You click that. The device then guides the user to identifying the point that's directly below the starting point. So you get a perfect 90-degree angle and a very accurate measurement. And So that it basically guides the device using arrows on the screen. So if you need to go a little bit to the left, you'll have a yellow arrow that says go to the left. If you need to go down a little bit, it'll direct you to go down. When those arrows have disappeared on the screen, you hit the arrow button again, and you then have your midspan measurement. It's presented to you on the screen. It looks, and if it's acceptable, you just hit the OK button and you're done. So that's the way the midspan tool works. In terms of, I'm not sure why it was showing up in this case as 0 feet 0 inches. Yan-Ping, do you have anything you can comment on?
Yeah. So in the current form, we don't have the midspan height tools built in that yet, but it is a tool available in MapSight that you can use to collect span height. So at this version, we are not importing the span height measure in MapSight into SPIDACalc, but that's something that we can consider for future improvements.
Okay, all right. I mean, because span height typically is not necessary for pole loading, so we're just not importing that information into SPIDA. That's what I'm hearing.
Yes.
Correct.
Right.
And then on the SPIDACalc side, so if a midspan has not been entered, we simply just show a 0, 0 reference on the screen. So that just kind of denotes if it hasn't been entered by the user.
Great. Well, that solves that mystery. Our next question is, can you measure down guy lead lengths?
Yes, that is performed using our missing line tool. That's the same tool you use to measure backspans and forward spans. Something worth noting is that while we're capturing that lead length, we're also automatically capturing the angle of the guy coming off the pole. Same thing with backspans and forward spans or service drops. We measure the distance with the missing line tool, but we're also capturing the angle of that line coming off the pole.
Right, and actually one of the other pole, the second pole that was in the sample project, actually did have a lead length with an associated annotated photo that had been used to set that lead length. So I apologize for not showing or maybe using that photo or that structure for the review.
Great, thank you. Our next inquiry is, does the MapSight collect wire type and size?
Well, we give you the ability to enter that information into MapSight, so we don't have an automated way for collecting that. That's a matter of the user visually identifying the wire size and then entering that into the appropriate field in the collection form.
Right, and the selections are generated from the client file that's selected when you're generating the form. So the wire types and the designations are client file dependent.
Excellent, thank you. So the next inquiry is, can you measure transformer height from street to bottom of the transformer?
Yes, and you would do that. The most common way to do that is from a true size image.
Right. Yeah, and that's interesting. Yeah, and I'm not sure if this made it through for this initial iteration. You know, in SPIDACalc there is a placeholder for that bottom attachment height for various pieces of equipment. I'm kind of expecting that's probably where the question came from. So, and I'm uncertain if that is something that's in this initial or something, an opportunity for a future iteration.
So the next question is, are cross-arm angles set in the field or in the back office?
That one, I am not sure on that one. I'm not sure how the client or the cross-arm angles are being determined in the JSON object, or if that's just allowing SPIDACalc to calculate it when it opens. I'm not sure if Yan-Ping can comment on that one.
Yeah, I can comment on that one. I think the cross-arm angle is not a value that we collect in the field. It's something that we assume when we build a model. So we assume it's relative to the wire. If we the field data collection collects the wire angle, and we try to make the cross arm, it has a relative angle to the wire, and sometimes it may not be the case. I think we see situations that it's not always perpendicular, so that's a limitation in the model.
Mm-hmm. So it would be something that the user would have to manually adjust over in SPIDACalc once the project file has been passed in.
Yes.
Our next question is, how does SPIDACalc handle the different bundles on a telecom strand? Could it do the combination of 5 cables of 15 different types lashed together?
Yeah, certainly. And again, all of those selections are dependent on the client file. Whatever client file is used to generate the forms for MapSight would be available. So all of that's configurable.
Okay. And we have an inquiry: how many pictures of the same attachments is required, different angles and so forth, to ensure the attachment height is accurate?
Yeah, for accuracy, you only require one photo. We're not combining photos to calibrate the image, if that's what's behind the question. We do recommend, by just as good fieldcraft, we recommend that you collect multiple true size images in the field just to minimize the chance of having to go back and revisit the pole. So if you take 3 pictures as an example from different angles, then you'd have a much higher probability of ensuring that one of those pictures is an ideal picture for measuring the heights of attachment. But you can, the accuracy, you could take one picture of the pole and get the same accuracy as you would if you took 3 pictures of the pole. The number of pictures you take has no influence or impact on accuracy.
Great. Thanks for clarifying, Mike. What is the minimum number of points to be collected in order to create a measurable photo? I have just addressed that.
Yeah, just one photo. Yeah, it's just one photo. That we leverage the laser rangefinder and the digital camera to create that calibrated image. So one photo will give you the accuracy you need.
Okay.
Or we'll give you the accuracy of 1 inch or better for attachment heights.
And then circling back about the fiber question, there's another question: are cable and fiber optic types preloaded into the software?
Well, I'm not sure. I guess if they're referring to the client file side or the MapSight side, but for us, yes. I mean, the selections are configured, so the client files are configurable structure that's tailored for every customer. So as Mike said early on, you can have a long selection of different client files that are available to generate the forms, that could be used in the field. So in that sense, for us, yes, the fiber, the cable types and whatnot are all configured items.
All right. And can SPIDA generate make-ready construction sheets?
Yeah, inside SPIDACalc, and I didn't show it given the topic for today, but there is a what we call a compare designs tool inside SPIDACalc that lets you take 2 designs for a given location, and typically the process, a little bit of background. I mean, for one given location, you can have multiple iterations or designs. for that one location. And often we'll see, specific for like make ready and joint use, you'll have an as measured design that would be coming from MapSight, and then that initial design could be cloned to reflect, and then a proposed attachment could be added, and then that could be cloned again if there's any make ready required. And then by using the compare design tool, that will generate a remedy statement or a make ready statement that can then be saved with the project. It can be you can copy and paste that statement out to a work print or a notification, etc.
Great, thank you. And if the ground line is not shown in the picture, will the software still give measurements between attachments on poles?
No, and we have a what we refer to as Fieldcraft. There's actually a nice video on our website that shows how to get accurate measurements when you can't see the base of the pole. And basically what we do is that's where you would use a survey rod to establish an offset point. So a number of our customers will just have a standard size survey rod so that for poles where you can't see the base of the pole, you just bungee that to the pole so you have something to reference and to establish a base offset so you know exactly where the base is. And I'll just point out. And I'll just point out the survey rod in that application has nothing to do with the calibration of the photo. It's there to establish a base offset because you can't see the base of the pole.
Yeah, I can add to that a little bit. Maybe there's some tricks that we can do to help that. Is if you have a photo that has the full pole in that as a true size photo, and you on that photo that you have the whole pole, you measure a reference height. For example, you find a bracket on the pole and measure the height. And in the other photo that you don't have the ground line, you create a base offset at that bracket position, and everything will be relative to that bracket position. For example, your bracket is at 27 foot high from the first photo, and you go to the next one. The next one, you cannot see the bottom of the pole. You just set the base offset at 27 feet, and then you can measure all the attachments on that photo relative to that base offset. Does that make sense?
I think it makes sense.
Okay.
Excellent. We have a question about MapSight. Does it provide a section or an area to enter pole defects such as rot, damage, cracks, that type of information?
Well, we certainly give you the ability to enter that as attribute data. And then we also, there is some information that you probably maybe you didn't see is there's information, or not information, options that a pole owner will usually set up and include in their client file. And so if, for example, there is the pole has certain types of damage associated with it, you can just from a drop-down list record that information in the field.
And if that information is passed into SPIDACalc, just to kind of complement onto that, once the damage is defined in SPIDACalc, then we, incorporate that. It's an option to incorporate the strength, determination strength loss to determine an effective loading on that structure, as well as discretely we'll calculate the remaining section modulus, moment of inertia, and other various pieces of information about each damage that is defined in the model. So very, very comprehensive.
Okay. Our next question is, do the wire size and type need to be known in the field and entered into MapSight when collecting information in the field?
Yes. Yes. I mean, the quick answer is yes, and that's just something that's done visually, but yes.
Yeah, for sure. I mean, because obviously it's important. It's important to across the spectrum. I mean, that selection determination is what has an impact on the properties that are associated with that wire and the wire tensions that are used, and obviously will appear in the loading results that we calculate.
Okay. And we have an inquiry about SPIDACalc specifically. Can the design details be saved to a spreadsheet file or another standard format?
Yeah, there's a number of reporting as well as reporting options, as well as the ability through our APIs to get data out of a project file. But there is an Excel-based report as well as HTML, which can be data can be extracted from that as well.
Great, thank you. At this point, I don't have any more questions available. We'll make one last call if anyone has anything that we haven't touched on. Now's your chance to send us an inquiry and ask the experts, if you will. And if we don't get anything else, I'm going to turn it back over to Mike McGill to close us out. So, Mike, go ahead.
Yeah, thank you, Tricia. We are, and we're up against our allotted time. So actually, I do see some additional questions coming in. We'll make sure that we follow up with you. For those of you who have asked questions that we were not able to answer, we appreciate all the questions and great questions. We will be announcing the release of the integration on September 1st. So. And the actual release of the integration will either occur on September 1st or shortly thereafter, but we will have an official announcement that we will make on September 1st and be providing a lot of additional and great information, and then also some sample and demo files that you'll be able to use so that you can get acclimated to the integration we're doing with SPIDACalc. With that, Brett, thank you. Thank you to you, and thank you to SPIDA Software for all the support that you've provided us in this integration process. We really do appreciate it, and I think it's going to be a great benefit for both of our customers. And so, Brett, is there anything else you'd like to say before we sign off?
No, just likewise. Thank you very much for the effort that your organization's put into making this integration happen, and we are looking forward as well, I'm sure our customers would say, to seeing this integration in action.
Beautiful. Thank you, everyone, for attending. We look forward to getting more questions from you, and we really look forward to making this a great experience for your organizations going forward. So thank you very much. Have a great afternoon, and we will talk to you soon.